Hi everyone! In this video, we will be discussing another factoring technique which is applicable to difference of two squares. Lessons required in this topic are perfect squares and their square roots. This second factoring technique is actually the opposite of product of sum and difference of two binomials. Recall that in product of sum and difference of two binomials, we are given quantity a plus b times the quantity a minus b, which will result into a squared minus b squared. This time, we will be given the difference of two squares, a squared minus b squared, and then we will express this as a product of sum and difference of two terms. Before we discuss some examples, let's have a quick review regarding perfect squares. Here are the perfect square numbers: 1, 4, 9, 16, 25, and so on. These numbers are said to be perfect square because they can be expressed as n raised to 2, or a number being squared. 1 is equivalent to 1 squared, 4 is equivalent to 2 squared, that is 2 times 2, 9 is equivalent to 3 squared, 16 is equivalent to 4 squared, and squaring 5, which is 5 times 5, is equivalent to 25. The exponent 2 indicates that the number is a perfect square. For variables, here are some of the perfect squares: a squared, b squared, c squared, x raised to 4, y raised to 6, z raised to 8, or any variable raised to an even number. For our first example, let's have x squared minus 4. Before we express this as a product of sum and difference of two binomials, let us check if the given is a difference of two squares. As we can see, it has two terms, and these terms are separated by a minus sign. The first term x squared is a perfect square. Second term 4 can be expressed as 2 squared, meaning it is also a perfect square. So now we are good to go. Set up two binomials wherein one has a plus operation, the other one has a minus operation. For the first term of these two binomials, we will get the square root of the first term of our given. The square root of x squared is x, so we will write x to the first term of our two binomials. For their second term, we will get the square root of the second term of the given. The square root of 4 is 2, and so we will write 2 to our two binomials. Therefore, this x squared minus 4 is just the same as the quantity x plus 2 times the quantity x minus 2. For our second example, let's have 9y squared minus 64. Check if the given is a difference of two squares. We have two terms here separated by a minus sign. 9 is a perfect square. It can be expressed as 3 squared. Obviously, y squared is a perfect square, meaning this whole term 9y squared is a perfect square. Our second term 64 can be expressed as 8 squared. It is also a perfect square. Now we can set up two binomials. One is plus, the other one is minus. For the first term of these two binomials, we will get the square root of 9y squared, which is 3y. For the second term of these two binomials, we will get the square root of 64, which is 8. So now, this 9y squared minus 64 is just the same as the quantity 3y minus 8 times the quantity 3y plus 8. For our third example, m raised to 4 minus 25 n raised to 6. It contains two terms and they are separated by a minus sign. The first term has an even exponent, so it is a perfect square. The second term, 25n raised to 6, since 25 is a perfect square because it is equivalent to 5 squared, the n variable contains an even exponent. That means this whole 25n raised to 6 is also a perfect square. Setting up a binomial, for the first term of these two binomials, we will get the square root of m raised to 4, which is m squared, because m raised to 2 times m raised to 2 is equivalent to m raised to 4. Next, we will get the square root of the whole 25n raised to 6, which is 5n raised to 3. So now this m raised to 4 minus 25n raised to 6 is just equivalent to the quantity m squared plus 5n cubed multiplied by the quantity m squared minus 5n cubed. For our trick, let's consider 2021 squared minus 2020 squared. Without the knowledge of factoring difference of two squares, one will do it in this way. He will square 2021 by multiplying 2021 by itself. Then he will also square 2020 by multiplying 2020 by itself. And then he will subtract the results of those two products. And I'm sure nobody wants to do that. especially if there is a more convenient way in answering this. So what is that convenient way? We will use the concept of factoring difference of two squares. Since the first term and the second term are both perfect squares and that they are separated by a minus sign, we can express them as a product of sum and difference of two binomials, just like what we did earlier on our three examples. So this one is just equivalent to the quantity 2021 plus 2020 multiplied by the quantity 2021 minus 2020. Now we can perform the operation plus here and the operation minus for our second binomial. Doing so, the sum here is 4041, while the difference here is 1. Now all we have to do is to multiply these two numbers, and of course the answer is 4041. You may use your calculator to compute 2021 squared minus 2020 squared, and I'm sure you will get the same answer, 4041. That's it for this video. I hope you've learned something. Thank you for watching. If you like this video, click on the thumbs up. You may also check our playlist regarding special products, and do not forget to subscribe.